Let's start with the next chapter today, class 12, surface chemistry. Okay, now when you're looking at the heading over here, surface chemistry, what does that imply? Surface chemistry means that over here we're going to study certain surface phenomena. So anything what is happening at the surface of the solid or the liquid or the gas. Okay, so we know that the solids, they have the most well-defined surfaces, right? Liquid surface is not very well defined, and gases, they do not have a surface which can be easily defined. So in gases we say that they do not have well defined surfaces at all. When we're talking of surface phenomenon over here, we say we are going to discuss a term which is known as adsorption. Okay? What is adsorption? It is the tendency of accumulation of molecules or molecular species at the surface. Okay? At the surface of a solid or a liquid. Most commonly we are going to discuss over here solids. On the surface of solids, that is known as adsorption. Why only solids we are saying? As I just said, that the solids, they have the most well-defined surface. Therefore, we study mostly adsorption as a part of solids. Okay? Now, what do we understand by this, what we have written over here? Tendency of accumulation of molecular species only at the surface. Right? As for example, if you throw a pebble in water, okay, when you take out that pebble, what do you see? That the surface of the pebble, that is wet, right? But if you try to break that pebble from inside, it is going to be dry. So it means the water molecules, they have accumulated only on the surface of that pebble, and that process, that is known as what? It is known as adsorption, right? In adsorption, we are going to study two terms further. The first one, that is adsorbate. Adsorbate. What is adsorbate? It is the molecular species which is getting adsorbed. It is the molecular species which is getting adsorbed or which is getting accumulated on the surface. And the second one is adsorbent. What is adsorbent? Adsorbent over here is the surface on which the process of adsorption, that is taking place. Okay, so generally what are we saying over here? That adsorption is a surface phenomenon. Okay, and the solids which have the surface of the adsorbent, which we are taking as solid over here, all the solids which have a you can say finely divided structure or an activated structure. Finely divided structure means that we are granulating it, converting it into smaller parts such that the surface area that increases, as a result of which adsorption also increases. Okay? And other term which we are going to keep using over here is activation. Activation or activated complex or activated solid surface means that we are heating any surface at a very high temperature such as to get some pores on the surface. Okay? So that is what two words which we are going to use over here. One is activated and the other one, that is finely divided. Right? Adsorption of gases specifically, when we are talking of adsorption of gases on metal surface, right? Then this term is known as occlusion. This term, that is known as occlusion. Okay, occlusion means what? when the adsorption of gases takes place on the metal surface. For example, adsorption of hydrogen over palladium, right? Hydrogen over platinum or hydrogen over nickel. So all these, they are examples of occlusion. When we are talking of adsorption over here, let's understand adsorption with the help of the following examples. Okay? The first example is, let's say we have taken a beaker. That beaker has a few gases like CH4, O2 and N2. Okay? This is a beaker having these gases. It's a closed beaker. Now when we are only taking the gases over here, let's say the pressure exerted by all the gases, that is equal to P. Then after that, what we do is we drop a piece of charcoal inside this beaker, and then we again measure the pressure over here. Let's say that the pressure that is equal to P1. We observe that the pressure P1 that is less than P. Why this is happening? This is happening because the surface of charcoal that has absorbed these gases, as a result of which the free gases in the container, they decrease, as a result of which the pressure also decreases. Okay? Another example which we can take over here, we are taking raw sugarcane juice from which we are preparing sugar. Okay, now this raw sugarcane juice, it is slightly yellow in color. It is slightly yellow in color. If we place a piece of animal charcoal in this, we see that the yellow color of the sugarcane juice that disappears. Which means that the animal charcoal that has absorbed the color from sugarcane. Okay? Clear ho gaya? In a similar manner, if we are taking silica gel, silica gel is small granules of silicon or silica. Okay? If we are taking these, we see that the air surrounding this silica gel that becomes dry. Air surrounding the silica gel that becomes dry. Now this dryness of air is because of what? It is because that the silica gel that has absorbed the water molecules on its surface. Okay, so these are a few examples of adsorption. Now, if we are trying to remove the adsorbate from adsorbent, then a reverse process that is going to take place. Which is known as desorption. So what is desorption? It is a reverse of adsorption. Okay? It is going to be reverse of adsorption. Reverse of adsorption means what? That when the adsorbate leaves the surface of the adsorbent, then a reverse process of adsorption is going to take place. That is known as desorption. So what all have we learned in this section? We have learned what adsorption is. Okay? Adsorption is a surface phenomena in which all the molecular species, they accumulate on the surface. Then we learned adsorbate. Adsorbate is the molecular species which are getting adsorbed. Adsorbate is the surface on which adsorption is taking place. Then adsorption of gases on metal, that is known as occlusion, and desorption, that is the reverse of adsorption. Then we learn another word over here which is absorption. Now what is absorption? Absorption is a bulk phenomena. For example, it is a bulk phenomena. For example, if we have taken sponge, right, and sponge we are we put it in water, what is going to happen? That sponge that is going to absorb the entire water, which means the concentration of water is similar on the surface as it is inside the bulk, or we can say that the absorption, that is a uniform phenomenon. Okay, the absorbed species is uniform throughout the surface and inside, it is uniform. Okay, so that is what is absorption. Now if we try to do the distinction between adsorption and absorption, let's see what are the differences. Let's just jot down the differences between adsorption and absorption. Okay, adsorption, in this the concentration of molecular species is more on the surface than in the bulk. Okay, which means that the molecular species, they do not penetrate inside the bulk, they will only remain in the surface. Whereas in absorption, the molecular species are uniformly distributed. They are uniformly distributed in the entire surface and bulk both. Okay? It is uniformly distributed in the solid or in the liquid. That is what absorption is. Then number 2, we say that adsorption is a surface phenomena whereas absorption is a bulk phenomenon. Right? This is another difference. Then third difference is that adsorption is rapid in the beginning. As soon as we will put the charcoal in a mixture of gases, immediately it will start absorbing. So it is rapid in the beginning and slows down with time. ठीक है? It slows down with time. Absorption जो है, that occurs at uniform rate. That is going to occur at a uniform rate. So these are the differences between absorption and adsorption. Sometimes what happens, both adsorption and absorption, they start taking place simultaneously. Such a process that is known as sorption. Okay, so what is sorption? When both adsorption plus absorption take place simultaneously. That is adsorption. Like for example, if we dip a piece of chalk in ink and we take it out, we will see that the ink that is absorbed on the surface of the chalk becomes blue. But when you break the chalk, we see that the chalk is wet from inside, but there is no ink marks which can be seen inside the chalk. Right? So that is the process of sorption, in which adsorption and absorption, both they are taking place simultaneously. Okay. Now let's understand why adsorption is taking place. Mechanism of adsorption. What is the mechanism of adsorption? Now in case of adsorption, we say that the surface molecules, they are in a different state from the molecules which are present inside the bulk. Okay, basically we have two kinds of molecules. One which is the surface molecules and the other ones which are what? Which are the bulk molecules. So both these surface molecules and bulk molecules, they are in a different state. Why? Because we know that when we are talking of the bulk molecules will be attracted by the other molecules surrounding it with exact or with the same force. Like for example, if we are taking a beaker and we are seeing a molecule which is present in the center, this molecule that will be attracted equally by all the molecules which are on all the sides of this molecule. Whereas when we are talking of the surface molecule will only be attracted towards inside, right? So the types of molecules or the state of molecules that is different on the surface than in the bulk. Then second, particles of the, as I just told you over here, that particles of the surface molecule, they experience a residual attractive force, and that attractive force that is going to be inward. Okay, as we are showing over here in this molecule, that attractive force that is going to be inside. Then as a result of this, what is going to happen, because this molecule is being attracted inside, it is going to attract the adsorbate molecules. Because the resulting force is an attractive force, as a result of this, the adsorbate molecules are attracted on the surface. The adsorbate molecules, they are attracted on the surface because of these residual attractive forces. Now, extent of adsorption will keep on increasing. As we have written over here, it is rapid in the beginning and slow down with time. So we say that as the adsorption molecules, they are coming in contact with the surface, the process of adsorption will keep on increasing till when? Till the entire surface that is covered. Okay, so as the surface is covered, with time, the extent of adsorption keeps on decreasing. Extent of adsorption that can be written as x by m, where x is the amount adsorbed and m is the mass of the surface on which adsorption is taking place. So we say that as the surface is covered with time, the extent of adsorption keeps on decreasing. Okay? So this is the third point. Then the fourth point is that whenever adsorption is taking place, is taking place, there is decrease in residual forces. Why a decrease in residual forces? Because the surface would be covered, right? The forces which are attracting the adsorbate molecules towards inside, that is also being covered, so they keep on decreasing with time. Okay, so this is one important point over here. So we say that whenever adsorption is going to take place, there is going to be decrease in surface energy. These are the conceptual questions which you can get. There is a decrease in surface energy because the forces of attraction, they are decreasing. Therefore, the surface energy also is going to decrease, and this energy which is decreasing over here, that is going to be released in the form of heat. So from here we can say that surface, the process of adsorption, that is exothermic in nature, isn't it? So what can we say from here? That the process of adsorption, temperature. Right? Now, because it is exothermic, then one thing we know that whenever the process is exothermic, delta H, that is going to be always negative. For exothermic processes, delta H is negative. So when the second thing is, if we are absorbing a gas on the solid surface, then whenever a gas is absorbed, what is going to happen? That the randomness of the gas will decrease because it is getting absorbed. Whenever a gas is absorbed, we say that randomness decreases, or in other words, we can say that the entropy change that becomes negative. Whenever degree of randomness decreases, delta S, that is going to become what? It is going to become negative. Now, for any reaction to take place, we know that according to thermodynamics, delta G should be negative for any spontaneous process. And delta G, that is expressed on the basis of Gibbs-Helmholtz equation, which is given by delta G is equal to delta H minus T delta S. Right? Now delta G will be negative when the value of delta H, that should be negative. Isn't it? Because what are we saying over here? That delta S is negative. Negative and negative, that will become positive. So the quantity T delta S over here, that is going to be positive. Okay? So we say that delta G will be negative if delta H, that is negative, and the value of delta H is greater than the value of T delta S. Is it clear? Now, as and when the gases that is getting absorbed on the surface, what is going to happen? The surface is going to be covered, right? As a result of which the value of delta H will keep on becoming less and less negative. And if the value of delta H will keep on becoming less and less negative, the value of delta G will also become less negative. Okay? And hence the extent of adsorption, that will keep on decreasing with time. Is it clear? Okay, so what are we saying over here? That with time, delta H becomes less and less negative. And the time will come when delta H, that becomes equal to 0. So if delta H become equal to 0, then what will happen? Or we can say that instead of 0, let's say that the value of delta H, that becomes equal to T delta S. Okay? So if the value of delta H becomes equal to T delta S, the value of delta G will become equal to 0. Okay? So we say that at this point, delta G, that becomes equal to 0, and this point, that is known as equilibrium. When the rate of forward reaction becomes equal to rate of backward reaction. So that is going to be delta G when becomes equal to 0. So the amount of gas absorbed, or we say that the extent of adsorption, that is equal to desorption. जितनी गैस एब्जॉर्ब होगी उतनी ही गैस जो है that is going to leave the surface. So this is the theory of adsorption. So let's see once again what are we saying mechanism of adsorption में. We say that there are two types of molecules which are present. One is the surface molecule and the other one is the bulk molecules. Both the molecules, they are in different states. Okay, we say that the center molecule, that is experiencing a force which is equal from all sides, whereas the surface molecule, it is getting or it is experiencing an inward pull. So because of that, there are certain residual forces which are formed over here, are going to be attractive in nature. Because of the attraction of these molecules, they can easily attract the gas molecules on its surface, right? So that is known as what? Adsorption. As and when the time keeps on, as and when the time is being covered, we say that the surface of the solid will also be covered. So if the surface is covered, the extent of adsorption that keeps on decreasing with time. Okay? Or there is going to be a decrease in residual forces and hence there is going to be decrease in surface energy. This decrease in surface energy that is given out in the form of heat, as a result of which the process is exothermic and delta H that is going to be negative. Okay? Now if delta H is negative and we say that when the gases are getting absorbed, delta S is also negative. Right? The reaction can only be spontaneous if delta G is negative and it is given by delta G is equal to delta H minus T delta S. Now the value of delta H is negative over here, but the value of delta S at the same time is also negative. Hai? So we say that delta G will be negative only if the value of delta H is greater than T delta S. Okay, so with time delta H that will keep on becoming less and less negative, and a time comes when delta H becomes equal to T delta S, therefore delta G becomes 0 and a state of equilibrium that is attained. So this is what from this section we can tend to get a conceptual question. Is it clear? Okay. Then next we go on to types of adsorption. So next is types of adsorption. We are going to do two types of adsorption. The first type of adsorption that is known as physical adsorption. Okay? What is physical adsorption? It is simply the accumulation of the gases on the surface of the solids by weak van der Waals forces of attraction. So the adsorbate gets accumulated on the adsorbent. How? By weak van der Waals forces. Okay, so these are temporary attractions which are taking place in case of physical adsorption. When we are looking at the characteristics of physical adsorption, this is the first characteristic. Then number 2, we say that the physical adsorption does not have any specificity. Or in other words, we can say that there is lack of specificity in case of physical adsorption, right? So there is no stronger attraction for any kind of gas. It is not that if we are talking of nickel or we are talking of palladium, it is going to attract nitrogen with more attraction and it is going to attract oxygen with less attraction. This does not happen. Okay, so there is no specific, this thing here, gas can be you can say attracted towards one particular solid. Any gas can be absorbed on any surface, right? Why? Because over here we are saying that the forces are universal. They are weak van der Waals forces of attraction. So we say that forces in case of physical adsorption, they are uniform. Okay? They are uniform, or you can say that they are universal in nature. Then number 3, in case of physical adsorption, the adsorption depends upon nature of the gas. Depends upon nature of the gas. Generally, it is said that gases which are more easily liquefiable, gases which are more easily liquefiable, they get adsorbed faster. Okay? They get adsorbed faster. We know that liquefaction of gases that depends upon critical temperature. What is critical temperature? Temperature above which a gas cannot be liquefied. That is what critical temperature is. So higher the value of critical temperature, more easily a gas is liquefied and more easily will it be absorbed. Okay, more easily a gas is liquefied, more easily it is absorbed, and liquefaction of the gases that will depend upon critical temperature above which a gas cannot be liquefied. So there are gases like sulfur dioxide, methane, carbon dioxide, they have higher values of critical temperature, therefore they can be easily absorbed. ठीक है, clear हो गया? Okay. फिर उसके बाद next, the physical adsorption that is reversible in nature. Reversible in nature का मतलब क्या हुआ कि when we have absorbed the gases on the surface of the adsorbent, they can be easily removed by changing the conditions of temperature and pressure. For example, if we increase the temperature, we can reverse the process of adsorption, or if we decrease the pressure, even then we can reverse the process of adsorption. That is, desorption can easily take place in case of physical adsorption. Okay? So, how can we reverse the process of adsorption? We can reverse the process of adsorption either by increasing the temperature or by decreasing the pressure. Either by increasing the temperature or decreasing the pressure. Then number 5, extent of adsorption over here increases with surface area. As we increase the surface area, the extent of adsorption that increases. Why this happens? Because it's a surface phenomena, so more the surface area of the adsorbent, more is going to be the forces of attraction, or more is the area which is prone to adsorption. Okay? So with surface area, so we generally what we do is to increase the surface area, we either finally divide the metal. Powdered substance, it has the maximum value of surface area. So powdered substances or porous substances, they are going to have more forces of attraction and hence more adsorption. Clear? So finally dividing the metal, or by making the metal porous or making the adsorbent porous, we can increase the surface area and hence we can increase the extent of adsorption. Then number 6, enthalpy of adsorption is less. What is enthalpy of adsorption? You can write down. It is the amount of energy released when 1 mole of the adsorbate adsorbs on a given area of the adsorbent. So what are we saying over here? That the enthalpy of adsorption is low, that is of the order of 20 to 40 kilojoules per mole. Why it is low? It is low because of weak van der Waals forces. 6 characteristics of physical adsorption, where the adsorbate that is getting adsorbed on the surface of the adsorbent by weak van der Waals forces of attraction. There is no specificity, easily liquefiable gases, they are more easily adsorbed. The process of physical adsorption that is reversible. Then increase in surface area that is going to increase the adsorption, extent of adsorption, and the enthalpy of adsorption that is low. Right? So the second kind of adsorption which we are going to discuss, that is the chemical adsorption. Chemical adsorption. In case of chemical adsorption, the forces of attraction are chemical bonds. Now in this case, it is seen that the surface, it has free valencies. Because of these free valencies, the surface can easily attract the adsorbate towards itself, as a result of which the temporary chemical bonds they are formed. Okay, so that is what forces of attraction in case of this, they are chemical bonds. The chemical adsorption is highly specific in nature. Highly specific. Why is it highly specific? That is because the adsorption will only take place if there is any possibility of bond formation. If there is any possibility of bond formation. Right? Now, if the bonds they cannot be formed, the process of chemical adsorption cannot take place. That is the reason why it is highly specific. Okay, then third, nature of the gas. Only those gases which can form bonds. Only those gases which can form bonds with the surface. Only those will be adsorbed over here. Okay, physical में what did we do? All those gases which are easily liquefiable, they can be adsorbed. But over here, only those are adsorbed. Only those gases are adsorbed which have the ability to form bonds. ठीक है? फिर उसके बाद next, the process of chemical adsorption, it is irreversible. We cannot reverse the process of chemical adsorption. Why? Again, because of formation of bonds. ठीक है? Only because of formation of bonds. Then in case of, when we are talking of surface area over here, surface area, the chemical adsorption behaves in a similar manner, has the same effect of surface area as that of physical adsorption. So we say that with increase in surface area, the extent of adsorption that is going to increase. Extent of adsorption that increases. ठीक है? And then last is heat of adsorption. Chemical adsorption has high heat of adsorption. Why high heat of adsorption? That is because of what? Because of chemical forces which are present. So the heat of adsorption is of the order of 40 to 400 kilojoules per mole. The high heat of adsorption that is due to the chemical forces of attraction. Okay? Now we have written down the characteristics of both physical and chemical adsorption. Can you write down the points of differences between the two in the tabular form? Okay? Physical adsorption, weak van der Waals forces of attraction, whereas in chemical adsorption there are chemical bonds. Number 2, physical adsorption, it is non-specific in nature, whereas chemical adsorption is highly specific. Number 3, the physical adsorption is reversible, whereas the chemical adsorption, that is irreversible. Okay? And number 4, the heat of absorption in case of physical adsorption is very less, whereas heat of absorption in case of chemical adsorption, that is very high. Okay? Clear ho gaya? Then we come to another term which is activation of adsorption. What do we understand by activation of adsorption? Activation of adsorption means to increase the extent of adsorption. Methods to increase the extent of adsorption. How can we increase the extent of adsorption? It can be increased in many ways. Like for example, we can increase the activation of adsorption by rubbing the surfaces together. So metallic surfaces are rubbed together. By rubbing, what will happen is the surface that will become uneven. It is not very smooth, or in other words we can say that there is going to be the residual forces. By making the surface uneven, it is going to increase. So metallic surfaces, they are rubbed together in order to make the surface activated towards adsorption. Okay? Then number 2, it is increased by taking the adsorbent in the powdered state. Why in the powdered state? Because the surface area is maximum in the powdered state. So in both the cases, whether it is physical adsorption or it is chemical adsorption, we have studied that by increasing the surface area, we can increase the extent of adsorption. Okay? Then number 3, adsorbing power can also be increased by heating the adsorbent at very high temperatures. Right? In very high temperatures in vacuum. So by heating it at very high temperatures in vacuum, number 1, the impurities, they are released from the adsorbent, and generally this, when we looking at the heating point over here, vacuum में तो करते ही हैं, they are also heated in superheated steam. They are also heated in superheated steam. So this makes the surface more porous, as a result of which the extent of adsorption that is going to increase. So these are the types of adsorption we have done today. Now in the next class we are going to study isotherms, adsorption isotherms, adsorption isobars, adsorption isosters, and the catalysts. Okay?